So today we're going to be looking at pediatric dosing, specifically relating to age and weight. First off, pediatric dosing based on age. So if the child is older than 1 year old, we would figure out their specific dosing using Young's rule, which is when we take the age of the child in years, divided by the age of the child, once again in years, plus 12, and then multiply that by the adult dose. And this would then turn that adult dose into a children's dose. If the child is younger than 1, we would use Freed's rule, which is when we take the age in months, divide that by 150, and then multiply that by the adult dose to get the age for that child. Now remember, this just gives us the amount, maybe in milligrams or whatsoever, per dose, or that they're taking at one time. Now, if you wanted to figure out how much they're taking per day, once again, you would have to figure out how many times a day they're taking it, or their frequency. That could be BID, TID, QID, every 6 hours, every 4 to 6 hours, whatsoever. You would have to figure out that frequency, multiply it by that to find your amount per day. This is specifically amount at once, or your dose. Now, to find the child dosing based on weight, which is normally what's done, it's the most accurate way to find child dosing, you would use Clark's rule. For this, you take the weight of the child in pounds, divide that by 150, and then multiply it by the adult dose. Now, if you are given the child's weight in kilograms, you would have to use our given, which is 2.2 pounds for every 1 kilogram. And remember, you would set that equal to whatever you're trying to find. So then you would put the amount, I'm just going to write number, of kilograms that you know that child is. And then you would put X for your pounds, because you're trying to find how many pounds you would need to put into your formula. Solve by cross multiplying and isolating X, and then you would get the amount of pounds to write in to solve your equation. Moving on. Some problems, you might need to find milligrams per kilogram. In this case, you might be given pounds, and you would need to do the opposite. So in this case, if you are given pounds, you would take the amount of pounds you are given. You want to know the amount of kilograms. So kilograms would be your X, and you would solve that way. When you find out how many kilograms, then you could plug that in. So let's just say your adult dose is 10 milligrams per kilogram. So whenever you see per kilogram and it doesn't say anything, we can always assume that's 1. So 10 milligrams per kilogram. And you're trying to figure out the dose for your patient, and your patient weighs 75 kilograms. So that's how you would figure that out. You would take your given, so the standard adult dose, and you would set that equal to what you know. So you know the weight of your patient is 75 kilograms, and now you're trying to find the amount of milligrams you give your patient. Cross multiply, we get X equals milligrams. Sometimes dosing will be given through dosing ranges. This is usually for narrow therapeutic range medications. So certain medications have small ranges where there's a certain amount that must be given to produce any kind of effect, any kind of desired effect from the medication. But at a certain amount, the medication can become toxic. So there's a very small window in which the medication is helpful and harmful. So the minimum amount you need to give and the maximum amount you can give. And if you're given a dosing range, then you need to make sure that the amount that you're giving the patient falls within this range. So for example, let's just say we have a 44-pound child and we're supposed to give 250 milligrams QID, which is 4 times a day. If safe dosing is 15 to 50 milligrams per kilogram per day, would this order be safe for the patient? So let's set up our problem. So since we're given pounds, we need to convert that to kilograms using our given. So remember, our given is 1 kilogram for every 2.2 pounds. Set that equal X kilogram, because that's what we're trying to find, to 44 lb, which I get from the weight of the child. If I cross multiply, we get 44 equals 2.2x. Divide both sides by 2.2, and we get x equals 20 kg. So now we know that the patient weighs 20 kg. Since we have this range, 15 to 50 milligrams per kilogram per day, and we know the patient weighs 20 kilograms, now we need to take that kilogram, so 20 kg times, and I'm getting these numbers right here. So I'm going to take my minimum, 15 milligrams equals 300 milligrams, and that's just for our minimum dose. Now I'm going to take 20 kg times, once again, our 50 milligrams. And this equals 1,000 milligrams, which is our max dose. So we know that we're going to have a dose between 300 milligrams and 1,000 milligrams per day to be safe. And if we take our 250 milligram that we're supposed to take QID, or 4 times a day, so times 4, this would be 1,000 milligrams. 1,000 milligrams, right here, is our max dose. So since this is our max, it is just barely safe.